talking today about slopes of perpendicular lines. We said on Friday, the slopes of parallel lines are always the same. The slopes of perpendicular lines are not. If you think about what perpendicular lines look like, something like this, right, where this is a right angle, those are not going to have the same slope, right? One's going to be positive, one's going to be negative, or if they're this way, one's going to be 0, one's going to be undefined, but they will not be the same slope, okay? Instead, with perpendicular lines, the book would say their product is -1. You're welcome to think of it that way. I think the easier way to think of it is the slopes of perpendicular lines are opposite reciprocals. What does it mean in math when something is the opposite of something else? What's the opposite of 7? -7, right? So opposite means you're changing the sign. If it was positive, you're making it negative. If it was negative, you're making positive. What's a reciprocal? Oh, look at you. That's fancy. So another way of saying it, you're going to flip it over, right? But it is the multiplicative inverse. That I don't think I've ever gotten that answer out of someone before. Good job. So take the reciprocal, right? If it's A over B, we're going to turn it into B over A. So you're going to change the sign and you're going to flip it, okay? So let's say I had a slope of 2/3, okay? If I want the perpendicular slope, what would the slope perpendicular to 2/3 be? It's going to be the opposite reciprocal. Yeah, Daniel. -3/2. So flip it over and change the sign. Okay, so it started as 2/3, it became -3/2. What if I had a slope of -6? What would the perpendicular slope be? It was negative, so it's going to be positive. It was 6, so now it's going to be 1/6, right? Because you can think of this as -6/1. When you flip that over, it would be 1/6. Okay? What if I had -3/4 as my slope? What is my perpendicular slope going to be? 4/3. Okay? Flip it over, change the sign. Okay? That idea right there is really the only thing you're going to do different in today's lesson. You're still going to plug it into the point slope form, which I'll show you in just a second. But other than that concept of the slope changing, the rest of it's going to look the same. So let's start with a graph here. All right, let's say we have -4, 2. Oops. And 0, -4 are two of our points. So -4, 2. Sorry, that's really messy. And 0, -4. Let's get the ruler out. All right, so we have that line, and then we have this line, -5, -3, 1, 2, 3, 4, 5, 1, 2, 3. So -5, -3 is here. And then the other point is at 4, 3. 1, 2, 3, 4, 1, 2, 3. So we take that, draw that line in. Okay, the question is, if that is our setup, are those two lines perpendicular? How would you figure it out? How can you tell if two lines are perpendicular? Opposite, what's that word? Reciprocal slopes, right? So if their slopes are opposite reciprocals, then they're perpendicular. Well, you just need to go the y2 minus y1 over x2 minus x1 route, okay? So if we start with, we'll start with the black line here. If this is x1, y1, and this is x2, y2, and we plug that into slope formula, it's going to be y2, so negative 4, minus y1, which is 2, over x2, which is 0, minus x1, which is negative 4. So negative 4 minus 2 is a negative 6. 0 minus a negative becomes plus a positive 4. What do you got to do with that? Do you want to turn this into a mixed number? We don't want a mixed number, right? Just reduce the fraction. So negative 6 over 4 would be negative 3 over 2. Okay, so the black line has a slope of negative 3 over 2. What should the red line be if it's going to be perpendicular? 2/3, okay? Opposite reciprocal. Flip it and change the sign. So if we do that, it would be 3 minus a negative 3 over 4 minus a negative 5. Okay, so simplify that. 3 minus a negative 3, that would be 6. 4 minus a negative 5 would be 9. What does 6 over 9 reduce to? 2/3, right? So when you look at these two, the question is, are they perpendicular? What's the answer? Yes, they are. We flipped it and we changed the sign, right? So we would say yes, their slopes are opposite reciprocals. Okay. Questions on that? All right. What if I don't give it to you on a graph? What if I give you 2, 7, and 3, negative 1? And then your other line has the points negative 2, 6, and 8, 7. Okay, I want to know, is the blue line going to be perpendicular to the red line? What do we do? Same idea, right? Find the slopes. So we're going to do, and if it helps you, you can label it. This would be x1, y1, and x2, y2. Or you could flip those. x2, y2, and x1, y1 is fine also. So you would do negative 1 minus 7 over 3 minus 2, which would be negative 8 over 1. And you can just leave it at that, really. If you want to just call it negative 8, that's fine too. For the red one then, if I did x1, y1, and x2, y2, then it would be 7 minus 6 over 8 minus a negative 2. 7 minus 6 is 1. 8 minus a negative 2 is 10. Are those going to be perpendicular lines? Why not? They're not opposite reciprocals. Okay, so this would be a big no. Okay, questions on that? Okay, so that's just finding the slope. Now we're going to do something different with that. This one looks a lot like one of them that you did in Friday's lesson, but perpendicular instead of parallel. So they're going to say, what is an equation? Or what is the equation of the line perpendicular to y equals 1/5 x plus 2 that contains the point 15, -4. Okay, this looks just like Friday's. The only difference is that one little thing. On Friday, it said what in that spot? Instead of perpendicular, it said parallel, right? So you're doing the same process. It's just that you need to change the slope now. So on Friday, you kept the slope the same. Today, you're going to change it. You're going to make it the opposite reciprocal. So if we look at this setup, you need to start here. And I think the biggest mistake that people make on these problems is they try to use the 2. The 2 is junk. We don't want it. It doesn't help us. We're not using it at all. So just ignore the 2. The only thing you need is the slope in that equation. So my slope right now is 1/5. Yes. Oh, I thought you had a question. Sorry. Okay, so if my slope is 1/5 and I have this point, x1, y1, what is my new slope going to be? My perpendicular slope? -5. Okay, so my perpendicular slope is the opposite reciprocal, which would be -5. Okay, so don't use the 1/5. Use the -5 because we want the new line to be perpendicular. And then we're going to use this point and take those two things and put them into point slope form. So it's going to be y minus my y1 value, so y minus a -4 equals my new slope, which is -5, times x minus my x1 value, which is 15. And then you just simplify that as best you can, but leave it in this form. You don't need to put it into slope-intercept right now. So minus a negative becomes plus a positive, so it would be y plus 4 equals -5 times x minus 15. Okay, and that would be your answer then. Questions on that? Okay, one more like that. And then we're done. Let's say I want the equation of a line that's perpendicular to y equals x plus 3 and goes through the point -4, -1. Okay, so let's just look at this part of it first. We want to be perpendicular to that equation. What do you pull out of that equation? What number matters? Just the slope, which in this case is not even a number there for you. It would be 1, right? There's nothing in front of that x. If it helps you to put a 1 in, go for it. But the slope of this line is 1. We don't want that line. We want to be perpendicular to it. So what's the perpendicular slope going to be? What's the opposite reciprocal of 1? -1, right? Because 1 over 1 flipped is still 1 over 1. So your perpendicular slope is going to be a -1. So you're going to use this. Remember, this 3 is junk. We don't want it. Don't use it. Don't try to put it in your equation. Okay, we do not want that 3. Instead, now we're going to take this point, -4, -1, and put that point and our new slope into point slope form. So this is going to be your x1 and your y1. So it's going to be y minus our y1, so y minus a -1 equals my new slope, -1, times x minus, and then my x1 is a -4. Okay, so if I truly want to simplify this, there's a couple things you can do. First, you can make your minus and negatives plus the positives, right? And then technically, you don't even have to have the 1 in there for the slope. You may. I don't mark you wrong if you leave it in there. But if you want to just make it a negative out in front, that's fine too. That's how the book would give it to you. It would say y plus 1 equals a negative x plus 4. Okay, so you can write it like this, or if you prefer, you can write it like this. Y plus 1 equals a negative 1 times x plus 4. Okay, so either one of those is totally acceptable. Any questions on that? Okay, one last thing. If I said we want to be perpendicular, God bless you, perpendicular to that equation, what's the number you're using? Right, you're going to take the negative 3/4, right? And you're going to flip it and change the sign. You're going to ignore the 7. Are you hearing me on that? This is junk. We don't like it. Get rid of it. Don't use it, okay? It did kind of come into play. It did and it didn't. In parallel lines, the only reason you would look at that number is when you write your new equation. What if so if we're thinking parallel here, okay, going back to Friday, if I had y equals 2/3 x plus 6, and then when I solved for the line parallel, it was y equals 2/3 x plus 6, what's the issue with that? If they're both a plus 6 and they have the same slope, it's the exact same line, which technically is not parallel anymore. So that's the only time that y-intercept matters, is just to show you that it's not the same line, it's a different line that's parallel. But with perpendicular, that will never be an issue. You could have the same y-intercept and they're still not going to be the same line because they're going like this, okay? So questions on that at all? Okay, so Tuesday or Thursday?